Hi everybody, I'm Harry, I work at Oasis, and before we start I'd like a show of hands in the wonderful crowded audience we have. But yeah, so today I'm going to be covering the Oasis Protocol, what kind of projects can you build with it. So first there's an EVM compatible chain with a confidential state and contract, so that's Oasis Sapphire. And then we also have a ROFL, which is the off-chain runtime compute with verifiable compute and internet access, and again, it also has confidential state. So we have a EVM ecosystem and an off-chain ecosystem where you can run lots of compute, pull data, post it on-chain, that kind of thing. So the QR code here goes to the cheat sheet, please. We have physical cheat sheets as well, and you can come visit our booth. So for Sapphire, the easiest way to get started is to go to the Explorer and request some tokens. So we've been in production for the past 2 years, but the testnet is free to deploy in and test on. On the testnet Explorer, there's a request test tokens button, and you'll see the tokens appear in MetaMask or whichever Ethereum compatible wallet you're using. And we have a handful of different prizes here. If you're thinking about what to build, we have several different tiers. For Sapphire, you do have to deploy contracts on-chain, but for ROFL, while you can communicate with Sapphire and it has an authenticated, verified link to post transactions, you don't necessarily have to deploy everything on Sapphire. You can run off-chain logic, but it is powered by our infrastructure. Also, to help you get started, we have a playground. So that's lots and lots of ideas and projects from hackathons in the past, where if you're thinking about need some boilerplates or want to fork something and see how they solved a problem, this is a really, really good place to start because there's lots of resources available. So I think I'll very quickly cover Sapphire. So it's a confidential EVM that enables a private smart contract execution. It's Ethereum compatible, but the contracts have encrypted storage. So the runtime state is encrypted, which means the node operators can't see what's going on. So if you mark a variable as private or internal in Solidity, only the contract will be able to access it, as users can only run public methods and access public variables. It also has a call data encryption. So you have an end-to-end encrypted channel between the dApp that's in the user's browser and the smart contract. So this gives you MEV protection for free because no one can see the contents of the transaction. Of course, we have 6-second block times, and because we're using a delegated proof-of-stake architecture, so we are an L1, you get a finality as soon as the block is mined, which can be really useful. So behind the scenes, we're using Intel SGX, which is the hardware-based security for privacy and confidentiality. So there's no proving time, and there's no complicated MPC. And importantly, because it's in a trusted execution environment, you have instant on-chain randomness available inside Sapphire Solidity contracts. So on the cheat sheet, we have a few different examples, and one is the Sapphire-contracts package on NPM, which gives you Solidity libraries to generate precompiles, but also generate key pairs, verify signatures, sign transactions, do encryption, and doing decryption. If you have any questions about more specifically, I can get into this afterwards. So the testnet, which you may want to deploy contracts on, here's a QR code for the faucet. We also have a testnet explorer, and here's the chain ID as well, so you can add that into your MetaMask. And I think to illustrate what we're doing with Sapphire is we have the sapphire.sol library that can be imported. So we have the sapphire.sol library which can be imported. So you can generate a random number by calling sapphire.randombytes. And they're all pre-compiled, so they're built in and they're very cheap to execute versus implementing this all in Solidity. One of the interesting things is if you can generate an Ethereum transaction and sign it on-chain using a key pair that's managed by a contract, then you can get gasless transactions. So the contract can sponsor your gas for you. Instead of needing the external infrastructure like ERC-4 773, or is it 47? Yeah. And so those of you who might have followed the account abstraction debates, we're working to make it much more simple and straightforward. And for us, it already works on production. We're using gasless sponsored transfers. I'm also thinking of one of the main differences with confidential EVM is you have to authenticate your users. So on the Ethereum ecosystem, everything's public, everybody can see everything. But when you come to confidential EVM, you don't want people to be able to impersonate you. So how do we verify the user's authenticity, that they control a wallet? And this starts to look a lot like the Web 2 world, where you would log in, it gives you a cookie, and the cookie proves who you are, and you can then send this through to the contract. So in this example, we're using sign-in with Ethereum, which allows you to sign specifically for a domain name with MetaMask integration that will warn people if they're on the wrong site. So it has like anti-phishing built in. And this is really easy to integrate with your smart contracts, but it shows you have to think a little bit differently about how to solve some problems or take advantage of the confidential state and the confidential runtime. What we're working on now, though, is we thought it would be really cool to use these trust execution environments to do things that you can't do on-chain. So instead of being limited to Solidity smart contracts, what if I want to retrieve data from the internet? I want to pull information from oracles. I want to submit RPC requests or interact across different chains. And it's obviously much cheaper to perform the compute off-chain. And we can use the blockchain part, Sapphire, for runtime signaling, communication, some locking, token transfers, that kind of thing. So we combine the two worlds. You have the performance of the off-chain world and the trust of the on-chain world. And we're calling this ROFL, so it's a runtime off-chain logic. And on our roadmap at the moment, we're looking at, well, this is perfect for AI. We want machine learning that's confidential, so you can prove that your model was trained on a specific set, or you can verify that inference is running deterministically. But it's not just high compute workloads. You can operate across lots of different chains by accessing the RPCs directly. You can manage keys inside. You can ask the contracts to manage keys for you. And there's a lot that you can do. So for gaming, a lot of chains are trying to increase the block speed. And we're saying we should actually move this logic. If you want real-time logic, let's move this off-chain so that you can have 30 millisecond, 60 millisecond responses. So anyone familiar with Oracle, with DEXs, you do need an Oracle behind the scenes to be able to fetch information from other chains, such as price quotes. And now you can run this inside ROFL. And you can trust it because it runs inside the trusted enclave, so you get verifiability, and to a certain extent, you also get privacy and censorship resistance. And that's all because it's running inside the trusted enclave. So each Oasis node can run ROFL apps inside the trusted execution environment, and they all have a light client, and they're verifying the attestations of the network and of the consensus level. So the ROFL app will communicate with Sapphire. So any storage, such as storing the private key, the ROFL apps don't have storage of themselves. So you would want to store that and manage it in the smart contract. And you can also open a HTTPS connection, which is something you can't do inside a smart contract. And that means you can connect to Amazon or eBay indirectly via Solidity. Or you can prove that you connected to Amazon and prove that to Solidity. But that's because the off-chain logic is non-deterministic, whereas the on-chain logic is deterministic. So with here, you've got the example where we're opening a HTTPS connection. We can do whatever programming we want. We can process the data, use JSON, CBOR, XML, extract whatever you want, summarize it, and then maybe you can store it again on-chain, just a summary, or you can fetch some extra information from on-chain in order to process it. So we made a small example of this. This is how you build an oracle using ROFL. That will fetch the price information from Binance, and every block it will submit a transaction which stores this data on-chain. So this is the Solidity part. So if you want to authenticate the ROFL component, each ROFL app has its own app ID, like it's in the App Store. So that means you can put the app ID of the off-chain component into the smart contract, but you can also update the off-chain component, so you can publish updated versions, which means you don't have to worry about upgrading the smart contracts to point to the new off-chain component. So what we do here is we've got a built-in as well to verify the identity of the off-chain component, and then enforce authentication so that only the off-chain component can submit new information. And of course, the submit observation submission is in the main function. But it basically just pushes the observations and price quotes, which you could also include things like a timestamp if you wanted. It's all written in Rust, unfortunately, so if you want to build off-chain components, this is the Rust side of things, which fetches the price quotes. Because Ethereum doesn't know anything about the floating point operation, we're multiplying it by 1,000,000 to convert it to an integer. So you have to be wary of encoding it for Solidity for the Ethereum environment. And we store this price by submitting a transaction to invoke the submit observation method in the smart contract. We also set the gas fee and then sign and submit transaction, which is using the built-in signer with ROFL. So that's the account that's running the ROFL that ends up paying for the gas. Although you can submit transactions and pay gas from other accounts if you want. And behind the scenes, we've got a light client that's broadcasting it to the network. And here's the boilerplate. So if you're going to deploy your ROFL app, you will want to anchor it to some chain, verify that it's started, and then we have the hook here, which is on every single block. We run the oracle and error out if that fails. So if you're running ROFL and you want to test your components, we have the full stack running inside a Docker image. We have the local net, which is the same as testnet and mainnet, where if you want to use precompiles to do any of the cryptography stuff or randomness, you can test this locally, and it has an instant mine. Or you can use the testnet, which has 6-second block time, so unit tests will run quicker locally if you want to do that. But it doesn't mean that if you just start up Hardhat, you won't be able to use the VRF, for example. So here we have the RPC gateway on 8545, and we have the local net explorer on 8548. And yeah, it works the same as testnet and mainnet. So for local net, you can add this into your MetaMask. So again, localhost 8545. We have the chain ID there, and you can change the mnemonic or use any mnemonic you want, and you will be provided with local net tokens if you use the standard test junk mnemonic. Oops. So secondly, for the hackathon here, I'd like to point out some resources. You have the docs.oasis.io, which is like the holy Bible for everything. We have the dApps/Sapphire subpage for everything related to Sapphire and building dApps. There's the ROFL subpage for everything related to ROFL, so how to build a full tutorial. And if you're building a cross-chain app, we have information about bridges on the dApps/OPL page. So OPL is the Oasis privacy layer, where we have 2 different bridges. One is router protocol, and one is seller IM. And finally, here's the cheat sheet. So we do have physical paper copies of those at the booth, or you can see the blue sheets of paper, and you can scan the QR code. So it's, you know what a cheat sheet is, it's A4 crammed with QR codes. and useful information. So we've got the wallet, the Explorer, the faucet, and how to run the Docker container, some code examples, all the package names. It's really, really useful, and you've got a cheat sheet there. So I think at this point, if anybody has any open questions, then feel free to ask. If not, we can talk afterwards. I can bounce some ideas around, that kind of thing. So thanks, everybody. Yeah.
So I'm not sure if I understood the connection between ROFL and the Sapphire mainnet. Like, is it the idea that the contract on mainnet will verify that only the contract on the T can call it? Like, there's a 6-second block time, in the T, in a ROFL, it's running instantly. So how does that work?
Okay, so in terms of how does the Sapphire mainnet verify the ROFL components? So we have a verification of attestation built into the Oasis ecosystem. So that means that instead of having to verify the ROFL component on every call, we have that behind the scenes, and then we have like a different type of address that shows that this has come from a specific ROFL app ID. Then that means that as long as you put the app ID into the contract, then when you're publishing your ROFL application, you can keep the same app ID, but update the version. So that means that you can have a lot faster development with very stable contracts on Solid or Sapphire mainnet. Does that ask a...
It's like with the Binance Oracle example, what would the flow be? Would someone be calling the contract on ROFL and then that's being automatically posted to Sapphire every 6 seconds, or like, yeah?
So in the example, every block is posting a transaction, is fetching the information, posting a transaction to Sapphire. But that's just one of the examples. The second thing is, well, you can run long-running tasks in the ROFL. So you don't have to submit transactions whenever. You can run cron jobs, you can do multiple threads, have some processing in one thread, have a cron job in another thread. It can query the chain, so you can have a contract that will notify the off-chain component that there's work to do. Or you could have the off-chain component connect via socket IO to some kind of pub sub, and you can distribute work to it there. The main thing is the main thing is that there is the authenticated link, and you can access the Ethereum ecosystem with gas payments and stuff either via signing your own transactions or going through Sapphire and using the ecosystem there. Fantastic.
So do we need an Intel-based system to run ROFL, or ROFL needs SGX, right? So do we need an Intel-based system to run ROFL, or can we run on Mac?
So the question is, do we need Intel SGX to be able to run Sapphire or to be able to run ROFLs? So if you're developing them, you want to run them locally, but if you want to deploy them, you will need SGX. So, So if you're developing for the hackathon, then as long as it works, you can run it end-to-end locally. You restart the Docker image, and it will automatically load up your ROFLs, and there's a command to build it. And then you've got the local net Explorer where you can see your transactions coming in. Unfortunately, because it's confidential, you can't debug it on chain. Yeah.